Well, good morning, everybody. Here's a plan for today. We're going to start off by looking at some very interesting satellite data before we move into just a quick recap of the recent precipitation patterns and what's really kind of going on throughout the Mississippi Basin into the southeast. We're going to focus a lot on that. I'll then kind of stretch this out into our multi-model forecast, looking at all the different precipitation patterns as this ridge slides out of the east toward the south. And then we'll just look out there longer range to see if there's any new indicators on what this pattern could do. And we're going to get to that about right here. So we're going to look at a sea surface temperature animation for the last 90 days, talk about what might be going on with La Nina, and also have just a quick look at the Atlantic. I think there's a signal in the Atlantic we need to be paying attention to. Last thing I'll do here is I'm going to look at some NDVI data in the Russian wheat belt. Just got a message this morning from a good friend of mine named Jude. He was just asking some questions. I think it's a good thing just to kind of look at it here. Okay, so satellite data to get us started. A couple things I'm very interested in watching. There is the potential for some tropical development here. It's low probability, but this moisture could get into parts of Georgia. And southern Georgia has been extremely dry as of late. So is northern Florida. And so to see just something, in that area that could move toward the southeast would be critical. You now have what was eventually named yesterday as Alberto moving on to Mexico early this morning. And we're just going to have to watch this area very carefully over the coming days for having just additional very, very heavy rainfall out of this pattern while Canada stays quite cool. But it was yesterday that was quite intriguing. So here you can see the northern edge of the moisture coming from Alberto here. We can watch the storms kind of running all along the periphery of this ridge. But there's one thing that caught a lot of our attention kind of in the meteorological community, and it was the moisture that was getting pushed back toward parts of New Mexico and eventually into Arizona. We're going to be looking at what may look like a bit of a monsoonal surge there, but it was right here that a lot of us were keeping an eye on. Now, in addition to the wildfire smoke, because we talked a lot about that, you can see it in California, see the fire going right there. I wanted to zoom in and show you something. So the convection that blew up here in New Mexico yesterday produced a very large dust storm, and we call these haboobs. So you can see right through here the outflow of these large storms, which put down hail and also did some wind damage, just advanced forward. And I can't wait to see some pictures of what this looks like from the ground. I mean, that's a massive dust storm just racing off to the west, and you can see the wildfire here that's on the border between Arizona and New Mexico. So that was captivating to see that take shape. All right, bigger picture things though. We are trying. This has been the theme, right? We're trying to figure this out for so long, and now even to the beginning of June, we've seen ridges of high pressure that have lived here. And they've been here. Sometimes one has skirted its way over toward the west coast, but the flow has gone around it, over the top, and just lived between this nice thermal contrast between the U.S. and northern plains of the United States and Canada. So central U.S., northern plains and Canada have been cooler. And we've just been looking at this, trying to figure out what it's been doing to the overall motion of the atmosphere. And I've made a case that there's still some important westward momentum in this flow that if it is lost, all of this talk of a hot, stormy summer goes quickly to a hot, dry summer. And the momentum I'm talking about is this. If you look at the anomalous winds, in other words, the difference from average, just since the beginning of June, this is the flow that I keep mentioning. That is stronger than normal westerly flow. So that's the westerly wind belt giving us stronger than normal westerly flow. So if you're curious what I want to know, it's that. Does this just maintain itself? Because at some point very soon, as the ridge comes out of the east and slides down here into the southern plains, this flow is going to start to produce clusters of storms that will roll right over the top of this. And some of that's going to be moving into some very dry area in the Ohio River Valley, possibly into the southeast. And while that occurs, the south is going to get very hot, and the risk is going to start to move into drought into this area. Now, this is an area that has been exceptionally wet for a long time. In fact, just recently through 7 a.m. this morning, we can see more of the moisture. This is on the northern edge of Alberto, making its way into the delta, coming into parts of southern Texas. While the storms continue to just roll right into this corridor, and they're going to continue to do that for a little while. But outside of some isolated convection over the last 3 days, we've not had much here. You can see some of this moisture getting all the way back into Montana, which was desperately needed given the drier stretch they had to begin June. But overall, I want to know, what does this continue to look like going forward? Now, as I just mentioned the risk of drought, I have to also mention the other side of this equation, which is who's had way too much rainfall, and it's becoming very problematic. I'm going to take you all the way back to mid-April in this particular graphic, but I want you to see how wet parts of the western Corn Belt and the upper Midwest have been as of late. And you just see here several ones, and that would mean this is the wettest spring on record for these particular climate reporting districts. We can also see this part of eastern Texas has been extremely wet. The Mid-South, which was very wet, has gone over dry. But it's interesting to note how dry the Northeast has been. So as this heat is coming in, this is increasing the evaporation rates, and this is an area that has I'm very concerned about it. I'm going to make a case for that in just a few moments. Now, outside of that, the moisture that is coming in, you're going to see it in the forecast here, is critical to Arizona and New Mexico. And what's happening is as that ridge moves into place, I mean, the best monsoonal years are when there's large ridges over Texas and Oklahoma and lows off of the coast of California. It just pulls the moisture into the southwest monsoon, which could be going, at this point in the year. Usually we have to wait till later when there's more heat on the northern edge of it, but we will be starting to pull some moisture into this area. And again, this spot right over here are going to be grabbing some moisture as well from this would-be tropical system that's moving on the backside of, or underneath side, south side of that ridge that's just hitting the Northeast right now, bringing in all the heat. So that again, April 15 up until yesterday, looking at total precipitation ranks. On the soil moisture side of it, down to 100 centimeters, this whole part of the upper Midwest is completely saturated. And this is becoming a significant issue with the crop that I don't think is being talked about enough, in my opinion. I have a colleague out running through parts of Iowa right now. He was in Sioux Falls, and it's Matt Reardon, you know him, and he just mentioned this is not the way northern Iowa is supposed to look this time of year, and he was very concerned given what we see right over here in central Illinois where we're from. Now the Ohio River Valley, getting into the mid-Atlantic, down to the Carolinas, northern Florida and southern Georgia, and then this pocket right in here in parts of Kansas, southern Kansas, but Oklahoma. Just areas that are now starting to show up with this kind of flash drought scenario that needs to be discussed. So over the last 14 days, if you want to see the percent of normal precipitation overlaid with some numbers here, the contrast in kind of who's been able to get this precipitation and who has not really shows up quite dramatically. Doubling up on rainfall in parts of Kansas, love to see it. But is it enough to undo the months and months and months of drought here? It's a temporary increase, but much, much more is needed. But look how dry it's just been right into this corridor. And then as you come from the Mississippi River Valley into the Ohio River Valley, the southeast, over here into parts of the mid-Atlantic, we can just see the extent of this dryness. In fact, I wanted to zoom in just on the eastern part of the United States to see that. And some of these numbers here, just in the last 2 weeks, some folks have received no rain. Others have received, 5 to 10% of what would be considered average. There's an interesting comment about the Mississippi River that's been going on with all the water on all the rain, on the headwaters of the Mississippi. We would expect it to be, really starting to fill up. But this big chunk of it and everything that comes in from the Ohio has really not been doing its contribution. It's not been there. So you take a look at the Mississippi River today, and after spending quite some time up here, 20, 26, 27 feet, we're back down to about 9 feet above or 10 feet above low stage. So that's what happens when the Ohio River isn't contributing what it normally can, or the mid and upper Mississippi, or really the mid-Mississippi Valley not contributing either. So where's it all going? If we just take a look at the next 7 days from the AIFS, one of the more intriguing things I'm going to watch, and I'll be honest, it's because it's in my backyard, it's going to be what happens right in through this corridor. As that ridge slides here, we've kind of made a case for this for the last 10 days or so. As the ridge slides south, we expect the orientation of these storms to just start to shift. They're just going to run the periphery of the ridge. Before that happens, take a look at the moisture that's coming into the Four Corners states. Take a look at the moisture that could be coming in from the tropical system, which is currently here, making its way toward the Georgia coast. And getting some rain eventually with this kind of breakdown of the massive ridge into parts of Ontario, Quebec, and the Northeast would be critical as well. What's got me very concerned is this. This is an area that I think we must be watching for the continuation of this flash drought scenario. And also take a look as the ridge builds back down into this part of Oklahoma. That's the other area. You get south of here, they've had plenty of rain lately. But right in through here, we've missed out on some of this. So how we see this pattern going forward, let's quickly compare the models, and then we'll take a look at the upper level heights. This is the national blend of models. Very similar story overall as to what you just saw. This is the WPC. I'm just looking for consistency, and I like it. It's making a lot of sense to me. I mean, gosh, anything we could get into here would be critical. As we then go from there into the European model, and finally the GFS. And the GFS is it's a really fascinating model to see, because I just want to show you something. Do you notice the orientation of the heavy rains that are here now in the next 7 days? If I were just to add on to this, I don't know, let's just go ahead and take this out to 45. What you're going to see now is the increase in storm clusters here. So these are these mesoscale convective systems that are going to roll off of the flow of the jet stream coming over through Canada as the ridge builds in this area. And these little tiny short waves just show up in the flow of the atmosphere and initiate storms. And the GFS is pretty aggressive on figuring that out. The other thing we have to pay attention to here is that the tropical activity. And we've got Alberto here. We then have the chance of something, there's some deeper convection here that's going to fire up behind it. And we see that this system farther to the north has a 30% chance of developing, but I don't really care how, to be honest, I just want to see its moisture get into this area as we need it. And we're going to continue to watch a few areas, especially in the Caribbean here, over the next 10 to 15 days for some continued development. We're going to come back to these ocean temperatures in a few moments to kind of make a longer term narrative, so sit tight for that. But in the near term, let's pick this up early this morning, about 7 a.m. Good initialization. We had some rain here this morning, heavier rain on the backside. There's the moisture from Alberto. And then watch right over here. The high-res NAM is picking up through the middle of the day today. You can see the storms just running around the ridge with the tropical moisture coming in. So this is all very consistent with the movement of the ridge. But just keep an eye down here for a moment. As we can see, whatever that circulation becomes as we work our way into Friday could move its way into Georgia, bringing in some chances of rain. But the reality of it is that this will be our most active corridor, could have some isolated storms farther to the north, even some stuff in the northeast out of this, as the ridge, which is here, begins to open by Saturday, right down here into the mid-south. So playing this out through Friday night into Saturday morning, very, very wet conditions rolling through the upper Midwest again, so heavy rains into this area. And that's going to be the case. That's, I think, what we've got here in the near term. And we're going to take a look at just how much rain we're going to experience in this area by looking at some probabilities in a few moments. Okay, upper level height pattern. I'm going to be honest, I've been using this a lot lately. I am really liking the artificial intelligence upper air height pattern. I think using the machine learning techniques to determine the pattern is, I think it maybe is a little bit more consistent than when you look at the ensemble spread. Does that make sense? So I'm liking this. That's why I keep showing it to you. And as we play this out, there's the ridge by Friday. Look at this. Came out of the northeast, slides right over the mid-south. By the time I get into Saturday, that's now squashed out, but living right in through here. And there they come. These are the little short waves we're going to watch. This is Saturday into Sunday, Monday, Tuesday. See how the ridge has now come from here to there? So there's some relief with cooler air coming in, much more active in terms of being able to produce precipitation. And we get out here to the 25th, 26th. I really think we're going to get some little wiggles on the back side of this, which could initiate storms rolling right into this area. This is about 6, 7, 8 days from now. And then as we go on, 27th, 28th, we've really just done it again. All of the heat's going to stay with the ridge in the south. But the reason the troughs keep rolling through here is because it's colder to the north. And that's where our flow stays. It just seems to make sense that we could get into the beginning of July, looking at that same type of pattern. Now, here's the big question I've got. The models have kind of trended more to keeping this ridge feature, sitting somewhere in through here, the farther out we go. They keep different troughs in the west, and we get some flow like this. This is a bit different than what I originally thought. I thought getting into early July, we'd watch another ridge open up here and slide, like the one is currently doing. But some of the model trends have kind of taken that out of the thought process. So when I look at the week 2 pattern, you're going to see just something a little different than we've seen lately. So let's get into the models just to kind of look at them and compare them here. As we play this forward, you're going to see a lot of that same story, right? So storms run the periphery of the ridge This is through the 22nd and 23rd. There's some better rains getting into the northeast. But by the 24th and 25th, there it is, the 26th and 27th. Look at that. See that high pressure cell? There's the frontal boundary. That high pressure cell is not heat. That's cool. There's some cooler air coming in at that time. And we're going to watch that push a front right through here. Now, what I want, okay, just be very clear, is that about a week from now, if that front does slide through and bring in the cooler air, can it drive moisture into the southeast with a frontal boundary? That's where we are desperate to get some moisture into this area. So again, there's the high pressure cell forming on the backside of the trough, diving into the Great Lakes, cooling everything down. You can see the extent of the frontal boundary. So this is going to wrap itself all the way back around here and even look like it's given some monsoonal flow. But that's what I think is going to happen. And then we play it out there and storms just start rolling again across the Canadian prairie. So probability-wise, this is the chance at staying under a half inch for the next 8 days, or 7 days, excuse me. What I'm very curious about is just this area, seeing it drop. I want to see that risk drop in that region as we go from day 7 to day 10. But overall, most of this time period is just isolated convection in this area. The hope of the tropical system driving some moisture into northern Florida and southern Georgia. And you can see the white. That's just where storms run the periphery of the ridge. On the wetter side of it, should get a new model run in here, yeah. Let's go back and just look out there. Yeah, let's go out 10 days. That's your 10-day probability of an inch. And if we step this up to 2 inches, look at this. Man, we need that. Hopefully the model will reset here. Maybe I've lost Weather Bell for just a second. I apologize. Maybe they haven't made the map yet. Anyway, we can see the wet conditions coming into these areas, just to make a point again here. All right, what about week 2? Now, this is where I mentioned we're going to see a little bit of change. This is where we could start to see the storm clusters reorient. And these are called MCSs, mesoscale convective systems. I just want to keep an eye on that area. I think actually the CPC's got this closer to right, because it would appear that you see a pretty big dry signal in through here. I do think there is the risk of staying dry inside of this, but I don't think that you should use the GFS to assess what's going to happen along the Gulf Coast. All right, so just compare the models, understand that we're going to keep this stormy upper Midwest pattern going, but I think the greatest risk of being the driest is going to be right in through this area going forward. All right, from there, let's talk temperatures, because we still have today heat watches, heat advisories that stretch, and even excessive heat watches that stretch a large area here from really Illinois, Indiana, all the way into Maine. Flood watches in a few places, including parts of the Four Corner states, and still a heat advisory that's out west as well. In terms of temperatures, I just thought you might like to see this from June 1 till now. This is what the average temperature ranks have looked like. So really interesting to see how all of this heat is building in, but most of June's been on the cooler side in this area. All right. So if we take a look at the min temperatures first, it was interesting. On my frost map, there was like this perfect circle this morning that showed up here. Like, what in the heck happened? Something went in with a missed data point, because I think the temperatures there registered at like -999. So my map kind of didn't know what to do with it. But you can see where the moisture is. These overnight lows barely getting down below 75. But are we able to use it to make storms is the thing. The atmosphere is so suppressed in here, we're not able to. On the high temperature side of it, this is today's highs getting into Friday and Saturday as we really expand the heat. A lot of mid to upper 90s, some places touching 100. The west starts to get hot again late this week into the weekend. Upper Midwest is cool. That's where all those, you can see right here the ring. See it? That's where all your cloud cover is going to be, and that's where your storms are firing up. So it's hot on either side of it. Hot in it, hot outside of it, but right through that ring, that's where the cooler air is going to be because of cloud cover. There's Sunday into Monday. Getting out there to Tuesday of next week, that's a very hot day for a lot of the lower 48. And then getting into Wednesday, a frontal boundary starts to drive in, and this is where we go. The 26th, 27th, that's where that cooler air starts to finally arrive for this larger region here in the upper Midwest, Great Lakes, and Northeast. So day 5 through 10 shows it, but hot to the south. Day 10 through 15. But the biggest difference, though, is that the GFS when compared to historical averages, is cooler than what the European is. That's the European day 5 through 10, European day 10 through 15. It's just a little bit different in the coolness that could be driving into this area during that time. And I'll be honest, I think that the European has probably got this closer to right. And the story is the same. If you keep this whole region cool and this region hot, the flow will continue to go. And we just need to see where the ridges live and how they end up just developing storm events that roll through much of the central United States and east. All right, bigger picture things. The risk of hazardous temperatures almost up to the 4th of July stays south of the jet stream. So the jet stream is here. It's all through this corridor. We've got the risk. And an area that just continues to show up as having significant heat and dryness area risks seem to be over here from the Carolinas getting into the mid-Atlantic. All right, from there, I want to show you an ocean temperature animation. This is going to reset. We're going to go back to March. And I want you to notice a few things. While you watch the cooler water show up because of the end of El Nino, it was in May that we got this dominant, there it is, watch right there, this very dominant PDO signal, negative PDO. But at the end of the animation, we kind of lose that contrast of the very, very warm water here surrounded by the cooler water to the north. And we've seen the jet stream extend through this. While all of that's going on, the Atlantic is very, very warm, and this positive phase of something called the Atlantic meridional mode is showing up, including the stronger trade winds in this region. So if you look, blue would indicate a strong trade wind, which comes out of the east. So here is the beginning of our La Nina, which we think will mature later in late summer and fall. But the stronger trade winds here have also caused some upwelling. Now this is low-level wind, 800, it's a mile above our heads. And here's the flow we're going to watch to see if anything touches that and slows it down. If blues begin to show up in the United States on a zonal wind map, that's where the big risk comes in of the pattern getting stuck and not relenting. Okay? I'm talking about stuck with high pressure and drought issues. But over this time, we have seen these trade winds beginning to gain some momentum. So I think about that and ask, well, where's that going to push the MJO? Because if you take note, the stronger trade winds, we even have some over here as well, the blues. So it means we got flow this way. And here we've got some of the warm colors, which means flow that way when you look at the on average. So that means MJO is going to live somewhere here, which is like phase 3-ish. And as we take a look at it, that is where over the next, all the way to July the 5th, the next 15 days, our best rising motion is. It's kind of right in this quarter sitting on phase 3. Now, thinking about this, I'm like, all right, how much is the MJO influencing the pattern? Well, if the MJO stays in phase 3 in July, what do we get? We get higher heights here that kind of back their way down. And take a look at it. Trough ridge. That seems to be consistent with this longer term look where the flow comes into the northwest and rolls across the Canada border. I'd say the only thing I would do to modify it is take these troughs a bit farther to the north and slide this ridge feature to about here. That's what I think the pattern's going to look like at that time frame. So what's the other part of this? Well, the AMN, the Atlantic Meridional Mode, back in May, I've showed you this once, was way out here, about 4 standard deviations above the mean. And if you look historically at what that might mean, this map is a correlation map. So the AAM is positive, and there's a positive correlation in this area with rainfall in July if the AAM is positive. What's contrasting against this is that the Pacific Decadal Oscillation, PDO, that's the ring of cooler water that's across the west coast of the United States and the Gulf of Alaska. Well, if you correlate it against precipitation, the PDO is negative. So if there's a negative correlation, it's wetter. So this is what's interesting. This would show up wetter. The southwest monsoon would get cranking, and we would be drier everywhere that you see the warmer colors. But this is why I'm questioning if the MJO is really, I'm so sorry, so many acronyms. If the Pacific Decadal Oscillation is really dominant, and by the way, let's just get in here and have a look at this. What I'm talking about is this cooler water in here and the warmer water there. Now, if the warm water was in a bullseye here and all of this was cool, I would only be focusing on the PDO. That is a strong PDO signal if it looks just like this. All right, but it's not quite there. So when we look at these correlation maps, if you want to know why we're struggling with telling you where precipitation is going to be, one, it's summer. Two, the contribution from any given teleconnection is transient and may not be dominant. And that's why I think it's so difficult to do. So I've stopped showing you month-long precipitation forecasts because I think they're terrible. But I think the temperature pattern makes a lot of sense. And this is going now, it's a 7-day animation through the middle of July and the end of July. There seems to be a lot of reason to believe that we keep just a lot of above average temperatures here. And is the model really anchoring this properly in this area? That's going to be the question. And some of these different features suggest it could be there. It'll move week in and week out. But if that's where we're going to anchor the greatest heat, that's where the ridges will be. And storms will just run the periphery of this. And as it slides farther to the west, you bring them down through here. It slides to the east, they then come back to there. I think it's going to be a shifting ridge right here that moves back and forth all summer long. I think that makes sense to me. What'll knock it out? A big hurricane. What could knock it out? I mean, a recurving typhoon, something that just changes the flow could really blast this thing out. But I don't know. This makes a lot of sense to me to think that July might look like this for temperatures. It'll come down to storm complexes to figure out who's going to get the rain and who's not. And that's going to be a thing we forecast inside of a week time frame, not months out. So let's go ahead and take a look again at some international weather just to finish this up. This is the next 10 days of temperatures. And it's important to see the heat that's in Central Europe right now. Also the heat that's in, it's now officially winter it's the winter dry season down here in South America, but very hot start to their winter. But take a look right in through this area here. Still Ukraine, much above average in terms of temperature. Western Russia, near normal, but still some dryness in Ukraine around the Black Sea. While the Indian monsoon is late but advancing, the Mayu front is stalled over the Yangtze, drier in the Manchurian Plain, drier in the North China Plain, wetter in the Manchurian Plain. Need to pay attention to that. And parts of Australia possibly picking up desperately needed rains as well. But the question I posed at the beginning, which my friend Jude texted me about this morning, he's like, what's this? Can you show me some NDVI data from here? So I sent him this link. And what I did was I picked out several of these regions in parts of eastern Ukraine, western Russia. And just so you know, this area right now is the lowest NDVI values on record. And our records here go back about 20 years with this particular data set. So I think there's a bigger story unfolding here in this part of western Russia. And the lack of a forecast of rainfall in the region, plus the above average temperatures, just continues to be problematic. Okay, that's all I got for you today. We'll talk again on Friday, and that'll be it this week. Thanks.